Switches for the DAC. The switches which connect the digital binary input to the nodes of a DA converter is an electronic switch. Although switches can be made by using diodes, bipolar junction transistor, field effect transistor or MOSFET. There are four main configurations used as switches for the DAC. Switches using overdriven emitter followers. CMOS switch for multiplying type DAC CMOS transition gate switch. These configurations are used to ensure the high speed switches operation for the different types. The switches using overdriven emitter follow. The bipolar transistors have a negligible resistance when they are operated in a saturation. The circuit shown here is arranged to a two transistor connector as an emitter follower, a silicon transmitter operating in a situation as a zero offset voltage condition. The case 1 is explained as an V is equal to V1 is equal to V2, that is the value of 1 plus 5.5 sound voltage, Q is the saturation, Q2 is the off position, voltage is 5 voltage. Case 2 also same as the one. Switches using MOS transmitter. Two-term pole MOSFET switch. As shown in the figure, the two-term switch is connected in series with the resistor R2R network. The MOSFET driver is connected to inverting terminal of the summing amplifier. The complementary output Q and Q drive the gates of a MOSFET M1 and M2 respectively. The SR flip-flop holds one bit of digital information of a binary word under conversion. The case 1, when the bit line 1 with S is equal to 1 and R is equal to 0, Q1 and Q is equal to 1 and Q is equal to 0, that makes the transistor M1 on, thereby conducting the resistor to the reference voltage, the resistor to the reference voltage, the transmitter refrains of an off condition. Case 2, S is equal to 0, R is equal, and interchange the values zeros and ones. This makes the transistor M2 on, thereby conducting the resistor R to the ground. CMOS transmission switches. The disadvantages of using these individual NMOS and the PMOS transistor are threshold voltage drop and PMOS transistor passing to the minimum voltage of an VTH. This is eliminated by using transmission gates which uses a parallel connection both NMOS and the PMOS. For this CMOS transmission gate, case 1, when the bit length BK is high, both the transistor M1 and MP and are on, offering low resistance over the entire range of a bit voltage. Case 2, when the bit length of one low, both transmitters and the transmission line inhibited. When it is having a low resistance in the lower positions, the PMOS offers low resistance in the upper position of the signal. Wide variety of these kinds of switches were available. Example CD4066 and 4051.